2 ohm. Here also the resistance is 2 ohm. Here the dot is here. Here the dot is here. J4. Here J4. Mutual inductance is J2. Across these two, J2. Mutual inductance is J2 ohm. Find Z equivalent. Z equivalent across this we have to find. Z equivalent means what? Z equivalent equal to V by V angle 0. Let us assume that we are applying a voltage of 0 angle divided by I angle theta. Am I correct or not? If you know current and voltage, we can find Z equivalent. This one only we can find, because impedances are given. Voltage is not given. But if you know the voltage and current, we can find Z equivalent. We have to find Z equivalent for this. The first parallel impedance is 2 plus J4. Here it is 2 plus J4. Second also 2 plus J4. In both cases, if the current direction is this way, means aiding each other. Am I correct or not? Aiding each other. To find Z equivalent, let us connect some voltage source, known voltage source, let us collect across this. 2 ohm, J4, 2 ohm, J4. Let us assume that current through this is I1. Current through this is I1. So current through this is I2. Let us assume, therefore, current through this is I1 minus I2. I1 minus I2. Or let us put, instead of putting this way, let us put this way. Loop current, let us put. What is there? We can put this way also. I1 here I2. The first loop current is I1, second loop current is I2. Let us assume that the voltage is, we are applying 1 volt, 0 angle. The angle is 0. Deliberately, we are applying 1 volt to find Z equivalent. To find Z equivalent, we are deliberately applying a voltage of 1 volt, angle 0. Now we have to find the current. If you know current, voltage is known, impedance is known, so we can find current. If you know current, we can find Z equivalent. The problem here is mutual inductance M. The problem here is across this mutual inductance J2, M equal to J2. M equal to J2. That is the problem. That's why it is not a conventional sum. It is a coupled circuit. This inductance and this inductance are interacting. In AC circuits, we have seen some sums, and that it is not interacting. There also we have seen inductance. We simply put J4, capacitor means minus J4 or 3, like that we put. If 2 coils are there, they are not interacting each other. Unless otherwise specified. They are not interacting. That's why we solved differently. Here they are interacting. The coils are interacting. The flux in the first coil interact with the second coil. The flux in the second coil interacting with the first coil. That's why J2 is there. That's why while writing equation, we should be very careful. For that, we have to consider we have to consider the dots. Here dot is here, here is dot is here. That's why while writing equation, we have to consider the dot. Let us write the equation. Let us write the equation. First equation, let us travel along I1. Let us travel along I1. If you travel along I1, there is a rise in potential. There is a rise in potential. Source means minus plus we mentioned now. There is a rise in potential. That's why plus 1 angle 0. Plus 1 angle 0 or 1 plus J0 both are same. 1 angle 0 and 1 plus J0 both are same. 1 angle 0 is equal to 1 plus J0. 1 angle 90 equal to 0 plus J1. 1 angle minus 90 equal to 0 minus J1. Am I correct or not? So these are all we must remember. So 1 angle 0. Therefore, voltage is 1 angle 0. What is the potential drop across this 2 plus J4 minus? Why I put a minus? Potential drop. So 2 plus J4 multiplied by I1. Am I correct or not? This is conventional. This is conventional. We are not talking about interaction. Now M comes into picture. Here M is there. Here M is there. This is M. This coil is M. Here some coil is there. We have to assume imaginary coil. It is not actual coil. Imaginary coil is there. That coil is M. Here also some M is there. While writing M, we have to put the correct sign. We have to put a correct sign. Here we have to write what is the current here? I1 minus I2. Am I correct or not? Instead of writing this separately, I can write this way, I1 minus I2. Current through this is I1 minus I2. Am I correct or not? This part is over. 2 plus J4 part is over. But the red color part, that is imaginary coil. How that imaginary coil came? Because of interaction between coil 1 and coil 2. What is the inductance of that coil? M. Inductance of the coil is M. Because of that, inductance of the coil is M. Because of that, reactance is there. That reactance is J2. That reactance is J2. What is the direction of I1 minus I2? Direction of I1 minus I2 is this way. Am I correct or not? I am talking I1 minus I2. So I1 I am traveling along I1. That is the meaning. I am traveling. That's why I took I2 as opposite. So I am traveling along I1. That's why minus sign. Here I put the minus sign. Potential drop. Here I put I1 minus I2. I am considering direction of I1. That is the meaning. Why I put minus? Because potential drop. I understand this point. Now we will come to that M. Here the M is because of not I1, because of I2. What is the direction of I2? Entering dot. What is the direction of I2? Entering dot. Here what is the direction of I1? Entering dot. That's why positive. Positive means M is positive. M is positive. Positive M. M only positive. Now we are traveling along current direction. That's why minus. Why I put minus? Because of potential drop. M is positive, not M negative M. Positive M. That's why I got minus 2 times. What is that value? In reactance, how much? J2. J2 multiplied by I1 minus I2. Am I correct or not? Sorry, I2 only. Sorry. This is because of I2 only, no? This is because of I2. I2. While writing M, we should be very careful. Whether M is positive or negative. First, we have to consider. Then, if M is positive, we have to consider the same sign as if J plus 2 plus J4. That's all. That way you can remember. If M is positive means same sign for 2 plus J4. That's all. What is the sign for j plus 2, 4 minus? That's why we put here also minus equal to 0. We got one equation. Simplify this equation. Simplify this equation. What you will get? 2 plus j4 I1 minus plus 2 plus j4 I2 minus j2 I2 equal to 0, equal to 1 angle 0, 1 angle 0 minus 1 angle 0 minus 1 angle 0. Now we can write group all I2 together. You will get you can get minus 2 plus j4 I1 plus this is minus, that's why plus plus 2 plus 2 plus j2 I2 equal to minus 1 angle 0, or I can say 2 plus j4 I1 minus 2 plus j2 I2 equal to 1 angle 0. This is the first equation. This is the first equation. Now let us write the second equation for second loop. Second loop, which is positive, which current direction is positive while writing second loop? I2 is positive, I1 is negative. So what we'll write, let us start from here. Minus, I am traveling along current direction, I2 direction. I am traveling along current direction, I2 direction. That's why minus 2 plus j4 I2. 2 plus j4 I2. This M is there. M is positive or negative, you have to think. M is positive or negative. This M is positive or negative, you have to think. Here current is I2 is entering dot. Here I2 is entering dot or leaving. Leaving. That's why minus. Here M equal to minus M. M equal to minus. Therefore, minus for that M, minus means M is minus. So minus is because of drop. We are traveling along current direction. Minus J2. M is minus J2. Why I put M is minus? That's why minus J2. Drop. We are traveling along current direction. That's why this minus sign. Minus J2. Whether I have to put I1 or I2? I1 minus. What is current in the first coil? What is the current in the first coil? What direction we are considering? I2. We are writing in terms of I2 we are writing. That's why current in the first coil is I2 minus I1. Current in the, by that only we found M equal to minus. Current in the first coil is I2 minus I1. While writing second coil, the current direction is I2 minus I1. Therefore, current in the first coil is I2 minus I1. I will explain once again. Don't worry. We will complete the equation first. Then we have to write for this M. This M is here I2 is leaving the dot. Here I2 is entering. That's why here also minus. Minus J minus. We are traveling against along current direction. That's why minus. J2 also minus. J2 also minus. Minus J2. What is I2? What is current through that? I2 only. Why I put I2? This M is because of I2 only. This M is because of I2 only. Have you understand that? This M is because of I2. This M is because of I2 minus I1. While writing second equation, while writing first equation, this is I2 only. If I1 minus I2 or I2 minus I1 comes, then only you should be careful. Okay. This J2 is because of I2 multiplied by I2. And here we are traveling against current direction. That's why plus 2 plus J4 along current direction or against current direction? Along current direction, because we are considering I2 direction. That's why minus 2 plus J4 I2 minus I1 equal to 0. Equal to 0. You understand this? You understand this? Except M, these are all you can easily write. Except M, all you can write. I'll first leave about M. Leave about M. Other things you'll see. First 2 plus J4. 2 plus J4. I2. Because we are considering I2 is the direction. Along current direction, that's why minus. What is our rule while writing KVL? If we travel along current direction, minus. That's why minus. So why I put minus? We are starting here. We are starting here. For this coil, we are starting. We are traveling along current direction, I2. That's why 2 plus J4 I2 minus. Why minus? We are traveling along current direction. That part is over. If we come here, we are writing I2 minus I1. Current through this is I2 minus I1. We are considering. So we are considering direction of I2. That's why we are traveling along current direction. That's why minus. This also over. This part also over. These two are simple. Now we have to consider about M. Now we have to consider about M. While considering M, we have to consider whether M is positive or negative. First coil, we are considering I2 direction. So what is the direction of current here? Here current is entering, I2 is entering here. Here what is happening to I2? I2 is leaving. That's why M is minus. That's why M is minus. If you consider this M, while writing this equation, consider this M. This M, I2 is entering here. Here I2 is leaving. That's why again this M also minus. M, whether M is positive or negative, finished. Understand this? Next, what is the current through other coil? We have to see. While writing this M, we have to see the current through the other coil. What is the current through the other coil? I2 minus I1. Current through the other coil is I2 minus I1. That we put. We are traveling along I2. That's why we are traveling along current direction. That's why this minus. Have you understand this? For this M we wrote. This M we wrote. Now we have to write for this M. This M, we are traveling along current direction I2. That's why this minus. So, while writing that M, we should not consider current here. We have to consider current in the other coil. What is the current in the other coil? I2. That's all. Have you got this equation? How many? 2 minus signs. That's why this is plus. 2 minus signs. That's why this is plus. So we can write minus 2 plus J4 I2 plus J2 I2 minus I1 plus J2 I2 minus 2 plus J4 I2 minus I1 equal to 0. If you simplify this equation, I will conclude. Want of time, I will conclude. If you simplify this equation, what you will get is, if you simplify this equation, 2 plus J4 minus 2 minus J2 minus 2 minus J2 4 plus J4 I1 I2 equal to 1 angle 0 0. 1 angle 0 0. You will get. Find the answer. I1. Find the answer. I1 and I2. If you find I1 is sufficient, why? I1 is the total current. I1 is total current. Therefore, Z equivalent equal to 1 angle 0 divided by I1 angle theta. Find I1 angle theta and substitute, you will get Z equivalent. I equal to 1 angle 0 divided by current is 0.3162 angle minus 71.56 degree. That is equal to 3.1625 angle 71.56. Whether the answer is correct or not, how to find? The angle must be positive because one inductance only. Inductance only. That's why it must be positive. Yes, we got positive angle. 3.1625 angle 71.56. That is the impedance. Z equivalent.